I'm Keith Miller. I'm the coordinator of Aviation Flight Management and Aircraft Dispatcher programs here at Southwestern Illinois College.
And I'm Nick Mansker. I'm the Avionics instructor here at Southwestern Illinois College, and our program runs for 49 weeks and starts in January.
Avionics is a new program for Southwestern Illinois College, and just to add to it, a number of additional aviation programs we have here that's in significant demand by many employers within the area.
I'm Nick Mansker. I'm the instructor here at Southwestern Illinois College for the Avionics Systems program. I've done avionics since I was 18 years old. I was United States Air Force for 20 years. I retired as a Master Sergeant in 2015, and I went back and worked for them for several years after that. Our program is set up to where we go all the way from the very beginning of just basic electronics and getting into the mathematics that it takes to do this kind of work. And then we have a 101 course that just talks about the aircraft and the basics of the avionics systems. And then we get into DC and AC circuits, and we talk about microprocessors, and we go all into computing, and then we start working on the actual systems on the aircraft. And then we go through all those and we talk about how to install the systems, how to work on the wiring, how to troubleshoot the systems, and how to test all the systems with different kinds of test equipment. We go very in detail on how to work on avionics systems in this course. So when you're done with this course, you're able to go out and get a job working for one of the manufacturers around here, or working for one of the airlines as a repairman type technician with the AET certification that we're preparing people to go and take. We're going to be putting a voltage into the base from our fingertips, because we're generating voltage from our body, and we're generating more than this 0.7 volts. And so that is going to allow the transistor to act like a switch. And then I talked to them about the science behind it, how the reason why these are more positive or more negative with the germanium or the silicon material, depending on what the transistor is made out of, is because they dope the material with something like arsenic. And that gives it an extra electron and makes it more negative. And then they can also dope it with indium, and that would make it more positive and take away an electron. So the imbalance between electrons makes it where the current can flow in the semiconductor. I'll take 3 of my blue leads, and 2 of my green ones. And I'm going to follow my circuit up there. I'm going to go from the plus V2 down to the top of my lamp 1, and the other side of my lamp 1. I'm going to connect that to my collector side of Q3 transistor. And then from the emitter side of that transistor, I'm going back up to the ground. And I'm putting this one on top of this right there, on where you can see from V2 to the lamp. That's that part of the circuit. And then I'm plugging this one into the base of that transistor. So when I turn this on, if I grab these with my fingertips, I'm going to be inducing more than that 0.7 volts is going to come from my fingertips, and turn the transistor on and turn that light on. Here we go. Ta-da! This is a AS76 Cockpit instrumentation system trainer, and this allows us to show the transition from the old analog instruments to the new digital glass cockpit style of instrument, or the electronic flight information system. And that's this display right here, which would be a primary flight display. You have an attitude director indicator on the top and a horizontal situation indicator on the bottom. And we're gyro stabilized right now, so when I push this panel like this, you see it shows our stabilization for our attitude director indicator. We have more sky when we're going up. We have more ground when we're going towards the ground. And if we bank to the left, we show that our horizon remains steady. We bank to the right, our horizon remains steady. And then if we yaw to the left, which is our rudder, our horizontal situation changes with that movement. And if we yaw to the right, our horizontal situation changes with that movement. So that's in a nutshell what this trainer does. It also does engine instrumentation. And it also pumps up for altitude over here. I'll go ahead and do altitude real fast for you. So what I'm doing here is I'm pumping the pressure down inside this chamber, which is simulating us going up in altitude, because as your altitude increases, your air pressure decreases. we go. We're going to pump out the air from this chamber, and then I'd like you to look at the altitude ticker tape here on the right side of the indicator. You can see it going up. And our vertical speed here. We also have airspeed on this side of 100 knots simulated, and that is coming from our pitot side of the pitot-static system, where the air is rushing into the pitot tube and being compared with that static air pressure. Alright, so what I'm going to do with this trainer, this is our AV22 PFD system trainer, and what we're able to do is teach students how systems work utilizing a test set that comes with a test set. We also have these points on the side where the students can troubleshoot with the wiring diagram, and we see that the test points are all here on the side, and the students are able to go ahead and test these points to determine which one of the wires are bad when there's a problem with the system. And we induce these faults through a computer interface that links with this trainer, and we can induce all kinds of different faults. There's several of them, and they break these wires inside electronically with a relay. And so when the students tell us that the wire has been fixed, in their scenarios we give them, then we go ahead and fix that wire with the computer input and then have them rerun the scenario. But what I'm going to do right now is show you a simple instrument landing system test with the test set here on our attitude director indicator and our horizontal situation indicator, collectively together known as our PFD, primary flight display. I have 110.3 megahertz programmed into my VOR localizer, and I have a test set here that's tuned to that frequency. I'm going to turn it on, choosing ILS, localizer mode, 110.3 megahertz, and you will see that we have a center deviation bar that is shown up on our horizontal situation indicator there, and we also have a center deviation dot that is shown up on our attitude director indicator there for our localizer. And our flag has pulled. So our flag was here on VOR Loc 1. I'll go ahead and turn it off to bring the flag back. Flag is there, center deviation bar gone. When I turn it back on, and I get a signal, the flag will go away, and the center deviation bar will be there. Okay, I'm deviating 1 dot to the right now. You see we have 1 dot deviation to the right. I'm going to deviate 2 dots to the right. When it goes 2 dots to the right, the center bar will hollow out, letting the pilot know he's almost off of the runway, too far to the left actually, because these are fly to indications. I'm turning off my 150 hertz modulation. There are 2 signals that come out from ILS, 90 hertz and 150 hertz, and you need both of them. The 90 hertz is on the left side, 150 hertz is on the right side, and if you don't have one or the other of those, then you have a bad signal. So this is doing what we expect it to do. It's showing us a flag when I delete the 150 hertz. I'm deleting the 90 hertz. We still have a flag. I'm bringing the signal back with full left deviation, and we have the full left deviation with the center of the bar hollowed out, and now 1 dot deviation and then back to center. So that's an instrument landing system test with a test set.